Hi everyone. I just wanted to hop on and do a couple of problems with you guys, kind of like a problem solving session so you can get an idea of how to approach problems and like the thought process behind, finding the solution, identifying, basically following the problem solving steps in the textbook that I mentioned earlier. So, I've selected a problem from your homework set for week 1, and this is going to be a vector problem. So we are given 2 vectors, and we're given the vectors in component form using unit vectors I and j, and we're asked to find the scalar product of those 2 vectors. So a vector can be written using unit vectors. So vector A is 4.30 I hat plus 7.20 j hat. If we were to draw this vector on the xy plane, I hat represents the x direction, so we would basically go over 4.3, go up 7.2 because j hat represents the y direction. And so there's our coordinate, right? 4.3, 7.2, that's our coordinate. The vector is going to point from the origin to that coordinate. So that's the vector A right there. And so then vector B we can draw the same way. So vector B is 4.80 I hat minus 2.10 j hat over 4.8 down 2.1. Somewhere right here, roughly. So that's our vector B. Okay. And the coordinate right there, of course, is over 4.8, negative 2.1. So components can be negative. And so what this problem wants us to do is find the dot product between the 2 vectors. And so what the dot product is, it's a form of multiplication. And you can express the dot product in 2 ways. The final result of the dot product, if you know the magnitudes of the 2 vectors, can be written as a b cosine of the angle in between those 2 vectors. So if we wanted to use this form to find the dot product, we would need to do a little bit of work, right? We'd need to find the magnitude of each vector. So the magnitude of each vector, right, remember, because a vector is basically like a right triangle. It's going to be the x component plus the y component squared. So that's some amount of algebra there, okay? And then we'd have the task of finding what the angle in between them is, right? So we're going to have to bust out a lot of trig. So just for completion, let me just write out what the magnitudes are. So I want you to recall that there is another definition of the dot product, which has the components. So that is how we were given those 2 vectors. So we should probably use this definition. So using this definition, the magnitude or the result of the A dot B is going to be 4.3. And then remember, if there's a negative sign, we need to preserve it, right? Because components of vectors can be negative. Okay, so I get 5.52. So that's A dot B. And in part B, we're asked to find the angle between the 2 vectors. So that's what we're going to use that first definition. Okay, because these are two equivalent definitions of the dot product, so you can set them equal to each other. So we can now figure out what the magnitude of A and B are, and we can solve for the angle phi. Okay, 8.39 for the first vector. Five 0.24 for the second one. So now I know phi is going to be inverse cosine 5.52 divided by 8.39 times 5.24. Three degrees. This is a review on working with vectors, and we're going to be using vectors a lot to describe actual physical properties. So knowing how to work with them is going to be crucial. So this is kind of the foundational tools that we need to learn in order to continue studying kinematics and the motion of objects. Okay, hi everybody. So let's do another problem. This time it's going to be from chapter 2, where we're starting to learn about how to describe objects in motion. So just as a quick recap, we saw that for objects moving under constant acceleration, we have a predictable set of equations that will tell us the position of that object as a function of time, the velocity of that object as a function of time. Okay, so those were called the kinematic equations. So in this case, in this problem here, we have a juggler throwing a bowling pin straight up in the air, and it has an initial speed. So this is a situation where we have an object in motion, which is the pin, the bowling pin, and it's moving in the vicinity of Earth's surface. So therefore, it is experiencing an acceleration in the y or negative y direction, right, of 9.8 meters per second. So this bowling pin we can represent as a point object, and it's going to be feeling an acceleration downward, right? So, and that acceleration is constant. Its value is negative g. So, right, we can make that acceleration a vector, and we can say that it's a vector pointing down with a magnitude of negative g in the y direction. So, what are the kinematic equations that we can use for an object that is moving under this motion? We can use the kinematic equations for the y position of the object. Where I've replaced ay, right, the acceleration in the y direction, with negative g. Same here. So these are the three main ones. There's also another expression, but I typically don't find myself using it too often, so I don't write it down very often. But it would be in a formula sheet for on the exam. You know, I personally just don't write it down very often. So what do we need? So we have a bowling pin moving around. Okay, it's got initial speed of 5.7. So let's write that down. Initial speed of 5.7 meters per second, and that's upward. So that's going to be a positive value, right? This is the y component of v naught. So this ball here, right, it's moving with velocity v upward initially, right? And so this would technically be the v naught vector, which is only going to have a y component of v naught y, which is 5.7 meters per second. So he's moving upward. His position is governed by this. So let's see what we're solving for. We're looking for how much time it takes for the bowling pin to return to the juggler's hand. So we're looking for the time. All right, so basically these two equations here have time in it. But we need to represent the conditions of how long, right? What time we're looking for. We need to represent them in the equations, right? So we're solving for time. Well, what are we going to plug in for everything else? So let's kind of diagnose that. Let's draw a picture. Okay, so the juggler is right here. And he's going to throw the bowling pin up, which is the dot, right? And it's going to go straight up. It's going to reach a max height, and then it's going to come right back down. Okay, so we're looking at its y position. And so what do we know at those different positions? We know here at the initial position at t equals 0, we know that the velocity of that pin is 5.7, right? J hat. In other words, the y component of that velocity vector is 5.7 meters per second. And at max height, do we know anything about that pin when it reaches its max height? We do. We know that when the pin reaches max height, its velocity will be temporarily 0. So at t equals the time at max height, we know the velocity in the y direction will be temporarily 0. And why is that? Because the velocity is going to be positive on the way up and negative on the way down. I'm not going to put v naught there because technically v naught is the velocity vector right here. This is just an arrow kind of showing the motion, right? So, but you can kind of see, right, the velocity vector is going to be pointing up on the way up to max height, and then the velocity vector will be pointing down on the way down. So in order for that magnitude of the velocity vector to go from being positive to negative, it's going to have to cross 0, right? So that's why at max height, we know that the velocity is going to be in the y direction is going to be 0. So, well, since we know two velocities, why don't we take a look at, let me label this equation 1 and equation 2. Take a look at equation 2, because we know the two velocities. We know the velocity at one point in time, we know the velocity at the beginning, and then what we need is the time, right? We need the time to come all the way back down, but we know halfway. We know the time it takes to go up to the top. So taking a look at equation 2, our Vy is going to be Vy at the top. Oh, this should not have a subscript 0. That's right, which is 0. And that Vy is equal to V naught y minus GT, where our V naught y is 5.7 meters per second. And our G is 9.8 meters per second squared. And then this time is going to be the time when the velocity is 0, which is our max height time. So we found our max height time. It's going to be 5.7 meters per second divided by 9.8 meters per second squared. And we can do our unit analysis to see that what comes out is seconds, which is what we would like to happen here, right? We want our equation to be consistent units wise on the left and the right. So we have 0.582 seconds. So it takes 0.582 seconds for the bowling pin to reach its max height. So let me ask you, how much time is it going to take for it to come back down? Right? How much time? So what we found is half of what we were looking for. This is half the time it takes to reach the juggler's hand again. And why is that? Why is that, you ask? How do I know that? Let's take a look at equation 1. Okay? Y equals y naught plus v naught yt minus 1/2 gt squared, right? This is a function, time as a function of, or y as a function of time, right? And what does this equation look like if you were to plot it with values? It's a shifted parabola. Okay, it's a parabola off the origin, and it's upside down because of the negative gt, 1/2 gt squared. And so it's an upside down parabola. Okay, a parabola is a symmetric function, right? You probably remember that from Calc 1 because you probably talked a lot about parabolas. It's a symmetric function, which means if you were to cut it right down the middle, what is on the left-hand side, which is time, it takes to reach max height, is going to equal this, right? That's a property of a parabola, right? It's a symmetric, you cut it straight down the middle and you can fold it in half, right? So this time is going to be equal to this time. And what is that? What is the total time? That's the time it takes the bowling pin to go up in the air, reach its max height, and come back down to its original height, which is where the hand was, right? So we know now half the time it takes. So twice the time, max height time. Oh, that was the worst handwriting I've ever done. The 2 times the max height, I'm going to have to just fix that, is going to be the time it takes to reach the hand again, which is what the question is asking for. So it's going to be 2 times 0.582 seconds. Which is about 1.16 seconds. Okay, the SI units for seconds is just S, not SEC. So, and so you may be wondering, like, how could there's no way that I could have figured that out. This is a very common, mental hurdle that students are faced with early on in this class is like, well, how, there's no way I knew all that. I would never be able to draw that out, on my own. Well, newsflash, no one is expecting you to rederive anything, okay? Like, we're not expecting you to be able to pull all this out of nothing, because the goal here is to do as many problems as you can and be exposed to all the different methods of problem solving so that when you do encounter a new problem, you are able to tease out all the logic like I just did here, okay? So the idea here is to expose yourself to all of these different problems. And the way you're going to do that is by watching videos like this, kind of watching how it's done. But what you really want to do is just try and tackle it yourself, okay? And work your way up to something like this. So, and the best way to do that is just by struggling with a problem, okay? Looking things up, but, you know, like in an active way, like looking in a book of what to do, or a phrase that is going to make things click. If you request a solution and just kind of like read a solution that's already been worked out, you're not going to be learning the problem solving process. So what I'll say is you want to expose yourself, do a lot of problems, but that doesn't mean read a lot of solutions. That means wrestling with the problem, okay? And going through the struggle and looking up resources and help without just being given the answer. All right, so I hope this helps, and let me know if you have any questions.